Fuck, bro. Bro, oh, bro.
is also a person. And so we want student and person to be connected like this. So we really want the student class to be the child class and inherit from the person class, which will then function as the parent class. So this way, all instances of student could also get access to methods from the person's prototype property, like the callH method, through the prototype chain. And that's the whole idea of inheritance. It's that child classes can share behavior from their parent classes. So looking at this diagram, basically what we want to do is to make person.prototype the prototype of student.prototype. Or in other words, we want to set the underscore proto property of student.prototype to person.prototype. And if this sounds confusing, prototype property, like the callH method, through the prototype chain. And that's the whole idea of inheritance. It's that child classes can share behavior from their parent classes. So looking at this diagram, basically what we want to do is to make person.prototype the prototype of student.prototype. Or in other words, we want to set the underscore proto property of student.prototype to person.prototype. And if this sounds confusing, callH method through the prototype chain. And that's the whole idea of inheritance. It's that child classes can share behavior from their parent classes. So looking at this diagram, basically what we want to do is to make person.prototype the prototype of student.prototype. Or in other words, we want to set the underscore proto property of student.prototype to person.prototype. And if this sounds confusing, then please just pause the video here for a minute and keep looking at this diagram for some more time. So that's why I created it. Okay. Now, anyway, we are going to have to create this connection manually. And to do this, so to link these two prototype objects, we are going to use object.create, because defining prototype manually is exactly what object.create does. Great. So let's go do that. So let's do what I just showed you on the slide here in our code. And it's important that you do this at exactly this point of the code. Okay. And I will tell you later why that is. So anyway, student.prototype should be object.create person.prototype. And with this, the student.prototype object is now an object that inherits from person.prototype. Now we have to create this connection here before we add any more methods to the prototype object of student. And that's because object.create will return an empty object. And so at this point, student.prototype is empty. And so then onto that empty object, we can add methods like this one. But if we did it the other way around, so if this was after we created this method here, then object.create would basically overwrite these methods that we had already added to the prototype object of student. Now you might be wondering why we even needed to use object.create. So why didn't we just do this? So student.prototype, right? This maybe would have seemed a little bit more logical to do. But in fact, this doesn't work at all. And let me actually show you why that is. So if we do student.prototype equal to person.prototype, then we will not end up with the prototype chain that we need. Instead, we would end up with this, which is a completely wrong prototype chain. And that's because here, we're actually saying that the student's prototype property and the person's prototype property should be the exact same object. But in fact, that's just not what we want. What we do want is the person's prototype object to be the prototype of student.prototype. So we want to inherit from it, but it should not be the exact same object. And that's why we actually needed object.create. All right, so let's get rid of this bad code. And here let's just say linking prototypes. And so now with all of this in place, we should be able to do Mike.callH. And indeed, we get the age of 17. Beautiful. So this worked just fine. And so let's actually now go analyze what exactly happened here. And we already know that this worked because of the prototype chain, but let's see exactly how. So when we do Mike.callH, we are effectively doing a property or a method lookup. So that is JavaScript trying to find the requested property or method. Now in this case, as we know, the callH method is of course not directly on the Mike object. It's also not in Mike's prototype. That's where we defined the introduce method, but not callH, right? So just like before, whenever we try to access a method that's not on the object's prototype, then JavaScript will look up even further in the prototype chain and see if it can find the method, so in the parent prototype. And that's exactly what happens here. So JavaScript will finally find the callH in person.prototype, which is exactly where we defined it. And that's the whole reason why we set up the prototype chain like this, so that the Mike object can inherit whatever methods are in its parent class, basically. So in summary, we are now able to call a method that is on a person's prototype property on a student object, and it still works. So that's the power of inheritance. Great. And since we're already here, let's also quickly complete the prototype chain. So just like before, object.prototype will sit on top of the prototype chain. So of course, we could still call a method like the hasOwnProperty method on Mike 2. It doesn't matter how far away in the prototype chain a method is. And with this, we now have the full picture of how inheritance between classes works with function constructors. And of course, with ES6 classes, it works exactly the same internally. Video using here. And also in the contour underscore, there's going to be method, right? Has a prototype too. So now this, and so in fact, that, right? And maybe it's even easier to visualize in the console like this, and we will fix that in a second. Should say student. So and we will fix that in a second. So, I mean, the prototype chain, everything is correct, but here it should say student. So you see that right now it says person, but Mike is actually of the type student. Okay, but anyway, here you see the introduce method that we defined earlier, and then if we go even further into this, so not this one, but this one, then you see, of course, the called h function, which is in the prototype of the prototype, basically, right? So what I said that we need to fix is this. So when we take a look at student.prototype.constructor, then remember that ideally this should point back to the student, right? But here it points back apparently to person. So actually we should use console.dir. And so you see that JavaScript now thinks that the constructor of student.prototype is person here. And the reason for that is that we set the prototype property of the student using object.create. And so this makes it so that the constructor of student.prototype is still person. So we need to fix this because sometimes it's important to rely on this constructor property. And so if we want to rely on that, it should indeed be correct. But that's easy to fix. We can just say student.prototype.constructor and set it to student. But let me just try out some more things here. So just to make sure everything works. So we can again use the instance. And so this, of course, is going to be, but if we try the same now with person, then that indeed should be also true. And so, in fact, it is. And so again, it's because we linked the prototypes together. So if we didn't have this, then this should be false. So of course, Mike.called h is not a function in this case, because the prototype chain is now not correctly set up to find this method. But let's quickly take this out. And so now indeed Mike is no longer an instance of person. And of course, Mike is also an instance of object, because it is also in its prototype chain. All right, so here we just proved that the prototype chain is in fact set up the way that we intended it to be. All right, and that's the end of a very long and so we and the prototype chain here. So we should now be able to say Stephen.callH, and yeah, that worked. And so you see that we just like before implemented prototype inheritance, but in a completely different way. And now just to make sure that we're all on the same page here, let's make sure that we really understand this big difference. And so let's take a look. Let's now go ahead and implement the exact same thing that we did in the last video, but this time using ES6 classes instead of constructor functions. So here again, I copied the initial person class that we built a bit earlier, so that now we can inherit from this class. All right, and so down here, let's now create the student class. Class student, like this. Now, as we know already, the class syntax hides a lot of the details that are actually happening behind the scenes, because classes are really just a layer of abstraction over constructor functions. But that's no problem, because we already learned how inheritance between classes actually works behind the scenes. So that's what we did in the last lecture and the coding challenge. And so now that we know how it works, we are ready to implement the same thing using classes, even though that hides how it actually works behind the scenes. So, to implement inheritance between ES6 classes, we only need two ingredients. We need the extend keyword, and we need the super function. So to make this student class inherit from the person class, all we need to do is to say extends, and then the person class. So CL, and this one I'm also going to call CL here, just to follow the same name. And that's actually it. So this keyword alone here will think about that. And this one will, but then even need to manually call, like person CL dot call. What we do instead is to call the super function, but call like we did before in the constructor function, remember? So here we don't need to do that. What we do instead basically becomes similar to what we don't need to specify the name of the pet. Necessary. I mean, it's not mandatory. And so the same goes for this additional parameter. So in this case, this new student class would simply have new methods and share all. But anyway, this was just to demonstrate to you that if you do not need any new properties, then you don't even need to bother writing a constructor method in the child class. But now let's take this back. This as well, and of course also this. And now let's see if this worked. And yeah, so now we have all the three properties here. Okay, now let's just quickly add the introduce method. So let me copy that from earlier. H. Here's. And now finally, let's look at how we can use object.create in order to implement a complex create. It's a bit easier to use and to understand, and so it shouldn't be too hard to implement a similar hierarchy between a person and student. So here, person proto, so this object up here, used to be the prototype of all the new person objects. But now we basically want to add another prototype in the middle of the chain, so between person proto and the object. And so what we're going to do is to make student inherit directly from person. So we're going to create now an object that will be the prototype of students. So student proto, and this will be, for now, an empty object. So object.create, and the prototype will be person proto. And that's it. And so now we can use this student proto to create new students. So let's create J, and object.create, create and it will inherit from student proto. And so now the student proto object that we just created earlier is now the prototype of the J object. So again, the student proto object is now the prototype of J. And the person proto object is in turn the prototype of student proto. And so therefore, person proto is a parent prototype of J, which means that it's in its prototype chain. Whoa, but that once again sounded a bit confusing. And so let's make sure that we really understand this by looking at a nice diagram again. So it all starts with the person proto object, which used to be the prototype of all person objects. But now, using object.create, we make it so that person proto will actually become the prototype of student proto. And what this does is that now, basically, student inherits from person. And so with this, we already established the parent-child relationship that we were looking for. Now to finish, all we need to do is to use object.create again, but this time to create a new actual student object. And of course, we make the student, so J in this course, inherit from student proto, which is now J's prototype. And like this, we created a nice and simple prototype chain. So J inherits from student proto, which in turn inherits from person proto. And therefore, the J object will be able to use all the methods that are contained in student proto and person proto. Now, with the scope chain correctly established, let's also add an init method to student proto. So just like we did here, is on any student proto, dot receiving the first name, then the birth year, and again, the course. And so now we can actually use the same trick that we used before when we use constructor functions. So what I mean is to take advantage, basically, of this init method so that we don't have to write the same code again. So basically the prototype, which is the parent prototype, right? So that is person proto dot init dot call, because once again, we want to set the this keyword to the this keyword in this method here. So this, and then the first name, and the birth year. And then, of course, resprint. J.init, and again, computers. So let's take a look. And yeah, that works. And yeah, so 27. And one more time, just to take a look here at the prototype chain. This prototype, in turn, has its own prototype, which is then the one which contains the call8 method. And so that is indeed person proto. So this is exactly the prototype chain that we just saw earlier in the diagram. Okay, and that's actually it. So in this version, we don't even worry about constructors anymore, and also not about prototype functions, and even ES. So not actually it. So in this version, we don't even worry about constructors anymore, and also not about prototype properties, and not about the new operator. So it's really just objects linked to other objects, and it's all really simple and beautiful, if you ask me. And in fact, some people think that this pattern is a lot better than basically trying to fake classes in JavaScript. Because faking classes in the way that they exist in other languages like Java or C++ is exactly what we do by using constructor functions and even ES6 classes. But here, in this technique that I just showed you with object.create, we are in fact not faking classes. All we are doing is simply linking objects together, where some objects then serve as the prototype of other objects. And personally, I wouldn't mind if this was the only way of doing OOP in JavaScript. But as I mentioned earlier, constructor functions are actually way more used in the real world, and actually it. So this is exactly the prototype chain that we just saw earlier in the diagram. Okay, and that's actually it. So in this version, we don't even worry about constructors anymore, and also not about prototype properties, and not about the new operator. So it's really just objects linked to other objects, and it's all really simple and beautiful here in the diagram. Okay, and that's actually it. So in this version, we don't even worry about constructors anymore, and also not about prototype properties, and not about the new operator. So it's really just objects linked to other objects, and it's all really simple and beautiful, if you ask me. And in fact, some people think that this pattern is a lot better than basically trying to fake classes in JavaScript. Because faking classes in the way that they exist in other languages like Java or C++ is exactly what we do by using constructor functions and even ES6 classes. But here, in this technique that I just showed you with object.create, we are in fact not faking classes. All we are doing is simply linking objects together, where some objects then serve as the prototype of other objects. And personally, I wouldn't mind if this was the only way of doing OOP in JavaScript. But as I mentioned earlier, ES6 classes and constructor functions are actually way more used in the real world. But in any case, it's still super important and valuable that you learned all of these 3 techniques now, because you will see them all in the real world still. And this also allows you to think about this on your own and choose the style that you like the best. But again, in the real world, and especially... So in the last lecture, we implemented a brand new class, which showed us the need for encapsulation, so for data privacy. And so let's now tackle this very important principle of object-oriented programming. Now, first off, remember that encapsulation basically means to keep some properties and methods private inside the class so that they're not accessible from outside the class. And then we simply expose some of the methods as a public interface, which we then call an API. And so those are the methods that we will allow other developers to use, so from outside of the class. And we also call this whole idea data privacy. And it's really essential to do this in anything more than a toy application. Now, as we learned earlier, there are 2 big reasons why we need encapsulation and data privacy. First, it's to prevent code from outside a certain class to accidentally manipulate or data that lives inside a class. And this can happen, for example, when someone interacts with an object's properties. That's the reason why we need 2 public methods. Then we can change all the usually called fields. So again, in these other more OOP languages when it first came out. Now, personally, in my own opinion, I'm not sure if this is actually such a big deal for the average JavaScript developer. So as long as you still along, like the deposit or withdraw methods, so those are simply public methods. And then finally, we also have private methods. And then at the end, so besides these 4, there's also a stack of these 4, which we're not going to talk about here because they're a lot less important. So we're just going to basically create also as private fields, but for now, let's start with public fields. So for example here, this locale here should probably be present on all the class instances, because it doesn't even depend on the input, right? So when we create a new instance, we pass in the owner, currency, and pin. So remember that from the last lecture. So yeah, exactly as we're doing here. So basically what I did here, by the way, was just to copy and paste this exact class that we created in the last lecture. But again, what we pass in are these 3 data points, and so the instance will of course then depend on these, but all of them will get this exact same locale, right? And so this is a great candidate for becoming a field. So let's declare a field, and we just do that here outside. So basically where we also place everything else, like methods, the constructor, and so on. Let's do this here actually before the constructor functions. And so this is now very easy. We just type locale, then equal, and navigator.locale, just like before, colons, which is a bit weird because we don't need those after the methods here and after this function. But here we do need them. All right, so we can just get rid of this. Maybe let's comment it out just to see the difference. So here we need to know this keyword, and also we don't use any const or let or anything like this. So just the name of the field and then the value. And so if we now, let's just log this account to the console, then just like before, we will see that the locale is actually here. Well, for some reason it is undefined, and yeah, actually here it is language, not locale. So now we get that locale, and if we were to create another account object, then this would get the exact same value. So again, this is now here on every single instance, but if we look at the prototype chain, then of course it is not there. So this here only contains the 5 methods that we have here, or the 4 methods plus the constructor. All right, let's say we want another one, let's say the name of the bank maybe. So this can also be on all of them, and so here, let's do again bankist, like we had in some other previous project, as doing this .bank, but having the a little bit more self-document rid of them here. And so yeah, these are the public fields, and so now let's move on to private fields. So private fields, the idea behind them is exact access from the outside. And so a lot of sense to protect this mid. No one can accidentally or even on purpose manipulate this data here. So right now, let's just see an example of that. So let's say that we do everything normal. For example, we just deposit some value here, let's say 100, but movements, and set them back to an empty array. So there we go. But this is very, very bad. So we do not want to allow this kind of interference with the data from the outside, manipulate it so that someone can check out. And anyone to allow to do this. So manipulating this data from the outside without using our public API. And so what we want to do is to protect this field. Once again, this actually doesn't even depend on the input here. So we can just declare it here, just like all the other fields, with the difference that we start with this hash symbol here. So hash, and then just the name of the field, which is just an empty array. And then we can remove movements array, called hash movement. And so here, we now need to change this name, movement. And yeah, so again, you see that now it is called movement here like this, or actually like this. So that's the hash, and that's the array, of course, with the 2 values that we specified here. But then what happened here, so this was earlier the line of code which reset our deposits and withdrawals, but now what this will do is to just create a brand new property and set that to an empty array. Class is no longer using this. So line of code here runs array with this weird name. Right, now here when we try to access this movement, it no longer exists. But watch what happens when we try to actually access our private movements that we just created. So indeed, we get private this hash movements inside of the class. You can actually, as you just saw, still see this property here in the account, but that's not what private means. So private simply means that the data cannot be accessed, so it cannot be read or be mutated from anywhere outside of the class. So that is exactly the goal of this. Great, now let's do another one, and let's now also make the pin here private. Now this you can only read here in the constructor, but not here. But it is here where we have to specify the private field. So what do? Well, just like with regular variables, we can just define the variable here first. So just like a let variable. So we just define the private field here without giving it any value, and then we assign the value to it right here. We just need to make sure that we change the new name. And so then this is all we need to do. Now without this line of code here, so if we just comment this out, then notice how this private pin here would just be undefined. So just like a let variable without any value. All right, but then we do this, and so then it becomes 1111, which is the value that we pass in here. We don't even use this pin anywhere here in the code, and so we don't need to change anything else. This was just an example here anyway. Now if we think about this, actually in this example, we could convert everything here to private fields, but let's keep it simple and just do these ones here. So I only did this one to demonstrate how we can first declare basically this field out here, and then define its value inside the constructor, which is where we have access to that input value of the pin. All right, so we already worked on these two. Let's now move on to public methods. So these public methods are exactly the methods that we have worked up until this point. So all of these methods that we have right here are right now public or API. Let's just, so that we actually give users in the rest of the code a way to read the movements. All right, so developers wait, and there. Like the public counterpart, but with the hash symbol. So remember how we had this approve loan method here, which was seen more of an internal method that is used by the request loan, and therefore we do not want pass should be and also to is kind of only determine whether method, and therefore let's just do this. And so just like that, we converted this public method to a private method. Very easy, right? Let's just really to make sure try to run this here. Approve loan with some value here, and then indeed private field. So here the browser also calls this a private field, must be declared in an enclosing class. Okay, great. So with this, we just removed this approve loan method from the public API of our class. All right, great. So just to recap, we talked about public fields, private fields, and public and private method. Public fields, static, private, static, public method here before in some of the earlier lectures, and so therefore, and so the so with this, we just removed this approve loan method from the public API of our class. All right, but from the public API of our class. field, the static fields, public method, no need, but less important self. The only thing you need to know is that static fields and also static methods are not accessible on the instance. So in this example, on this account. So they're not inherited from the prototype. Example, so static methods, example, static self. The only thing you need to know is that static fields and also static methods are not accessible on the instance. So in this example, on this account. So they're not inherited from the prototype here to the class instances. So instead, they're only accessible on the class itself. So just again, we just use the static, and then let's call here a test method, which will simply return true. And so again, we use this on the account itself. So now we cannot see anything. So let's just console.log something here. And there we go. So there is the test. And yeah, we use this directly on the account class, not on the account object that we created through the class. And if we make this private, then of course, yeah, we get exactly the same error as before. But we could then use this here on the inside. So again, not really that important, I think. And so yeah, I'm just not spending a lot of time on this here. All right, and with this, I basically showed you all there is to know about object-oriented programming. Just one small quality of life, but also very common improvement that we can make to these methods. Remember how we chained array methods one after another. For example, a filter, map, and reduce. Now by chaining these methods, we could first filter an array, then map the result, and then reduce the result of the map all in one line of code. And we can actually implement this exact same ability of chaining methods one after another in the methods of our classes. So let's say that instead of doing this, so always account1.deposit and then .withdraw and then whatever we want to do next. So draw 50 of 12 and up. And again, doing all this in one go. And this is actually a very common pattern that you will see in object-oriented programming. For example, when you use some external libraries, as we're going to do anytime C in Java. So basically just starting with the object here, then the pot result, you want to withdraw again, implement this. Well, let's actually think about it. So again, what we want to do in this line of code is withdraw on the result of this. Now we can only call in order to be able to run this line of code, this and all the other because it's an object. So let's just, well actually this is not a good. So yeah, let's take this one out of the chain. Let's just work, so that's just this, return this. And then also return this here, and of course outside of the if. So always at the end, so the very last operation inside the method needs to be this. Now here we get this error, this.approve loan is not a function. That's here. All of them, of course, need to be called on an instance of this class. So in this case, this account one right here. So in order for this one and this one and this one and this one to work, they need to be called also on an account object. And what is this account object? Well, inside these methods, it is just this. And so then all of the thing here, this whole withdraw function, all the way until the end. Chainable. So this is yet another really nice tool in your object-oriented programming toolbox. So as we reach the end of this section, let's quickly review all the terminology around classes, because there is so much different stuff going on, so a lot of different features that you can use. And since classes are probably the way.
Hi everyone, this is Harnoor. After 200 applications, 10 plus rejections, after an actual interview in the dreamland, which is Silicon Valley, 1 out of 4 tech jobs are right here, including for product managers and including for software developers. Why I started my career from scratch after leaving Microsoft, and what is my status update. Here we go. So first of all, I wanted to share that I really wanted to move here. I traveled the world and I wanted to work for a startup. Mission was to work for a startup, not for big tech. I want to change. I want to be in a fast-paced environment. And number 2, I want to use Parkinson's law. Parkinson's law states, more things you try to do, more you keep yourself busy, more you're actually able to achieve. That's what I learned. For example, when I was like just doing YouTube, you know, I was like just very relaxed. I would like sleep till 10 a.m. pretty relaxed, and I would get less stuff done as well because things are in my control. But when I am now working for a startup, right now I am working for a startup as well. I got a pretty cool position. I'm talking about it. Now I am able to achieve the startup goals as well as YouTube goals, both because I am like putting every goal in a time crunch of 1 hour or 2 hours. Look at reach my destination and that happened. First of all, my journey of 200 applications. I moved ASF, and I started with pretty much generic platforms like LinkedIn. They were all BS. They don't work for me. I tried actually fine tuning them, but what is definitely LinkedIn. Here you four platforms which are my favorite. Number one, I'm going to walk you through is definitely LinkedIn. Here you can actually start with the jobs which have easy. Start with that, and then you go into unicorns. Unicorns are like recently unicorn starter, whatnot, attentive, etc. Zip, etc. Zip is a cool startup. So you start with, you play with all you need. Next I went to Greenhouse, to the job application that Date posted with. They gave me hidden page which not many people know. It's actually conversations on, this is the one for April, and a lot of people actually talk about job boards, and this is free filters behind, because who is wise, you can choose how big this. So well, just call early startups. So here I like messaged a lot of these founders. I said, hey, I moved to Silicon Valley to go all in and to work for a startup. This is my background, coming from Microsoft security. And then a lot of startups actually reply to me. They are actually is work no. But now beyond this, you can also go to Sequoia. Sequoia is like the S tier. Beyond that, no venture capital comes close. In this Silicon Valley, it's saying that, you know, even Sequoia says that. Sequoia says any company exists in a world that is successful. It's either two scenarios. One, they were backed by Sequoia. Number two, they were rejected by Sequoia. That's what they say. So going through companies backed by Sequoia, all these top VCs, you can find Benchmark, there's General Catalyst, find their pages and apply. Anyways, now beyond this, I want to talk about how I got interviews and how was my experience and where I'm working right now and why. So my experience is, when I was interviewing for so many companies, I felt like even after 1 month of lead code, doing 50 plus problems, when I was preparing for Microsoft, I did 100 problems. Now I did 50. After trying to cover like a lot of like blind 75 problems, I felt like I am still not able to be the best lead code person. I can answer questions 8 by 10 scale, in a scale of 10, 8 by 10, but not 9 by 10, not 10 by 10. That's why I kept on getting rejected. It was like I will miss a test case, I will miss here and there. So the number one reason I was rejected among those 10 companies was that I needed to do more mock interviews. I still remember when I nailed Microsoft 4 years ago, it only happened because I was doing mock interviews on cool platforms like, you know, I don't want to name them. They are like, they don't exist as much now. They're outdated. But anyways, cool. Now you can do on like Discord channels of CS careers and find someone to do mock interview or pay someone. But I was doing 30 mock interviews. It was like I can easily brush up my lead code without doing much mock interview, and it didn't happen. So I was giving only 8 on 10 answers. They need 9 on for a tech company for 3. Lot of concept. Give me hash map collision. Jeez. Question was, give me hash map collision strategies. How would you create a hash map that barely collides? I was like, I'll think of a mathematical formula that collisions is minimum. That was not enough, of course. I completely forgot this question. Studied for the Bitly system design problem, but that even wasn't enough to recall at the time of the interview, because I'm not using these interview preparing strategies every day. Am I like interviewing for like a take home exam? So a lot of companies will give you, like, if you're preparing for any interview, Android, iOS, and like show that, and I nailed that. Take home exams, I passed all of them, pretty much all of them. And then when the interview happens, one error happens, and then I have a mindset that let's keep building and come to production ready app. So that means if any failure happens, you need to know why, and timer in your head. I'm like, I have 6 for, and interviewer has it to show startup experience from here, and be the person having obsession with the product, that, oh, it's okay, I think I have enough clarity, let's just work on it and do it fast enough. So that's why I'm like pretty much enjoying, this is my journey, and let's see where it takes me, but I'm really looking forward to next.
Welcome to the Ultimate Next.js course. In this course, you will learn everything you need to know about Next.js, from the basics to more advanced concepts. So by the end of the course, you'll be able to confidently build fast and scalable applications.
Rick.
Let's assume that I was at one company and making 200K.
Know what happened in college. So you went to University of Mumbai. Is it true or not?
Yeah, it is true. Everything on my CV is true.
You went
So,
to Georgia
like,
Tech as well. Is that true as well?
it is. Was still embarrassed to say that this was my motivation for doing work at multiple places. And so what I instead told them is, I was very excited to build both the companies.
So hello everyone, today we have Soham here, the most famous software engineer in the world and most famous, most talked about in Silicon Valley. You've been called everything from genius to a scammer. How do you introduce yourself to someone who has never heard about you?
I mean, I usually just say, hey, my name is Som, I'm an engineer. There's this famous line from my email that went viral, like, I don't have a life, that's all I do all day. That's usually my go-to intro as well. Like, that's how I talk about myself in general. But yeah, I guess at this point, the moniker I'm using is everyone's favorite founding engineer. That's got me quite a Twitter attention. So yeah.
You are everyone's favorite, not just because of your hard work, dedication, and you're amazing for even hardest you have worked in a week.
I mean, usually I was actually maximum at probably like 2 places at a time, but these startups are very small, right? So they require much more than your typical 9 to 5. You have to be generative. I was in most cases like the first engineering or the first few hires on the team. What that also meant is that we have to go beyond engineering to talk to customers. If there is an outage or something like that, you have to quickly attend to that. So I'd say in most cases, I was either sleeping or working. This was my schedule. Maybe on a weekend, like once a month or a couple of times a month, I would have some time to go out and then spend with family or friends. But most of it was essentially just like, either of these two activities and maybe an hour of gym somewhere squeezed in the middle. Yeah.
Interesting. So at most you've only worked for 2 jobs at a time. Why everyone talks about 3 to 4?
I actually don't know. Like, a lot of information went out there and it became so sensationalized that some people said, for some people at some media outlets, very popular media outlets, that I worked at 20 places at one time and I had a dev shop. And so I think the nature of the topic itself is, we're living in a crazy times, right? Like, companies are laying off people and there's a lot of at least there's a lot of visible difficulty in a job market. I wouldn't say that is the case. Like, I think people should try to talk to more startups and then they would know that that's not true. But there's still demand for very skilled people. It's exaggerating that just kind of flooded one after the other.
And what about the claim 140 hours a week? So that's like 20 hours a day, every single day. Walk us through a day.
So basically, when I don't have any experience on going any podcast, I'm very camera shy. So when this whole thing happened, the first thing that I did was I reached out to a founder friend of mine that I worked at previously, and I said, hey, how should I handle the situation? Because I was also not on Twitter, right? So I did not even know what a repost is and things like that. So he said, hey, just make a public appearance. These people from TBPN had reached out, so he said it's a good network to just go out and then tell your story, and then it's up to the world to believe it or not, but at least so that was what I did. And what happened is there was one I don't know what, like a media source or something, that claimed that I worked like 140 hours to get to where I was, and they've made a story behind my life. And so my personality as an individual is to keep things casual. I like to keep it light. Like, people around me that know me well, they will probably say this. And so I was trying to play on the situation that no one likes to work 140 hours, meaning I was not working 140 hours, but I was working crazy hours. I wasn't tiling, but mostly I also don't sleep much. I sleep probably like 4 or 5 hours a day. Sometimes I go, a day without sleeping, but it was essentially trying to say that there are crazy claims being made out of me, so no one likes to work that many hours, slightly more than 100. But yeah.
Fascinating. I still want to know the details because, like, in 2 jobs, so how focused.
These places I worked at, one of the reasons that I think people miss about me being able to, make through these interviews was the fact that I actually genuinely cared about the business model, what the vision could be down the line. I was very generative in terms of saying, hey, this is what we should do. These are the features we should build, which is, not like your typical engineering setup where someone's telling you do this and, like a product manager is saying, this is what you should do, and then you do that, or, spec out the entire feature for you and you're just like engineering or architecting it. And I think that actually helped me. A lot of people, get burnt out. I have had friends, or founder friends who have been, going crazy hard at it, and then they eventually end up burning out themselves out, and then they, started like something new, or they went on a short trip. With me, the thing is, like, I was very interested in all of these places. I keep saying my own company. Unfortunately for me, the risk appetite for starting a company and potentially not paying yourself is not something that I can go through right now. But I would have done that even if I was working for a startup that I was building. Was very productive. I think that would be my goal of the day. Like if I have starting my day, at least these are the things that I want to ship, or at least try.
Interesting. So you said you were on the verge of not burning out when the whole teammates around you were burning out. Why is that? Why you?
I think it was involved in coming out anew with AI, or in the field that I was in, and what that meant is you have to like
working in school, you did not have a computer, and then now I want to know about the college you went to. So let's go to your resume.
CV doesn't have all experiences; it has curated experiences. There was basically, depending on what company I was interviewing at, like I would think about, oh, is this work relevant to them? And if it was, I would put it there. So which is I was saying that this is a little bit different.
No.
So which is I was saying that this is a little bit different.
No, what happened in college? So you went to Mumbai. Is it true or not?
Yeah, it is true. Everything on my CV is true.
You went to Georgia Tech as well. Is that true as well?
It is. It was an online program that I'd applied for, and then I never went. The thing is, it was like everything
happened in college. So you went to University of Mumbai. Is it true or not?
Yeah, it is true. It is in my CV because I was using the same CV everywhere. It's very recently that I started, like actually modifying my CV, but I was using the same CS program. I had enrolled in like an online dev OMSCS program. And so during the interviews, I would clarify to people that, hey, most people actually did not even point out. They didn't care where I'd come from or what my education was. Which was very interesting. I think this was very different for American startups than the Indian startups, is that they never asked about my college or what I did there or anything as such. Like they didn't care about, have not gone to colleges, or believe in, I'm not saying everyone should do that, come from. And so like it never came up in the conversations. That has been the year when I, actually started considering masters. Did not go that year, because of COVID and everything, could not afford. Said that if you want to do an online masters, we will pay it for you. So that, and I thought, leave being at a startup. Like I basically, the thinking that was going in my head was that, what do I expect to get out of, like my grad, like, to grad school. The University of Mumbai is the only education I've had.
Got it. So the dates you make up for Georgia Tech 2020 to 2022 is false. We can say that you knew all the concepts you were learning from Georgia Tech, but you did not go there.
The CV just so that I could have conversations with people I was interviewing that, hey, I am doing a part-time master's program. A lot of it was also immigration reasons, like I was a plus degree. At big tech, like Amazon and things like that. So I did a few internships at big tech, like Amazon and things like that. That was when I was in India. And then after that, I joined a company called Better Finance. It was a YC startup. There were I'm good friends with founders there. They called Better Banking back in the day. And then they named it to Better Finance, but it was an insurance tech / but kind of like a founding in started work because I was able to work at a startup and actually see what it takes potential 5 years worth of engineering. I'm not even kidding. We were connecting to people's bank accounts, dealing with financial transactions and things like that. So I was like, okay, working at startup is insanely cool because you can basically be a founder yourself if you're early enough in the team, but not have to do all the administrative things, right? That typical founders do. So that was my first founder experience. After that, I joined a company called Alan, which built conversational assistant. At this time, like I was not having any financial issues. I was working at one place only at one time. The way Alan came to be is they used to sponsor a lot of hackathons in Mumbai, and I mean not Mumbai, but like India in general. And they were in conversational assistant sphere. That is some, and that is when that I thought is okay. If I am able to work at two places, I can and by the way, these people like Synthesia, I got founders from Synthesia reached out to Command Bar founders, and then they candidly asked me that boost productivity, like my time to think has reduced, but effectively I'm still spending.
How would you say that how would you say to the world, to the hardworking software engineers out there, what they should do to make more money out there, make more impact, and be the next Soham Parekh in terms of hard work and dedication and focus instead of a scam?
So I think like at the end of the day, what you want to build is skills for the longer duration, right? Like you could be working at 10 places or 5 places, but if you're like not learning much, or if you don't have time to learn much, then eventually it's going to become a problem. So I think the only two things I would say is that obviously, keep time for you to be able to learn things on the side. If you're able to do that while working, that's awesome. But if not, then, like I think it's important for you to have some time where you can keep up with the industry because it's changing very rapidly and you don't want to be left behind. And the second thing is, just be candid about it. I think people are okay with, like, I think the way founders think is they care about work getting done at the end of the day. So as long as that is true, I don't think people will have any problem. As long as you're like candid about it. Like obviously if you have hidden this and it comes out, then they are responsible, like I said, to answer to other engineers on the team, right? And if they are okay with one engineer doing this, then they have to be okay with or open to at least the risk that someone else will also come up and they can say, oh, this person already did that, whatever, right? And so I think that is another thing, like just be candid about it. I don't think people think about it as drastically bad as it's set out to be. And I think it's not bad to think about like financial independence in general. Like I'm not in that situation. I had different reasons, but yeah, that's all I had to say. And yeah, thank you so much for having me here. I think it was awesome to get a platform to actually